Hello everyone, I'm Valeria Juarez from IEEE in Mexico. The title of my paper is Indirect Electrification through Hydrogen, Evaluating Distributed Generation for Fuel Cell Vehicle Autonomy. Indirect transport electrification through hydrogen could promote the development of battery electric vehicles by reducing the stress caused by this technology. An energy management system has been implemented on a FPGA board to run hardware-in-the-loop simulations to measure how much excess of hydrogen could be available to be fed in a fuel cell electric vehicle after covering the energy demand of a microgrid.
FPGA is a reconfigurable integrated circuit that can be programmed to execute complex computational tasks, and it is used to simulate real-time operations with actual data, serving as a first approximation to implementing energy management algorithms in real systems. Here, the hill works as the energy management system. Basically, the FPGA is responsible for calculating the power demands of the different microgrid components to meet the load. The energy management algorithm used by the HDL coder was previously compiled, obtaining the specific file to be loaded into the FPGA board for later use in the simulation.
So, we performed 1-year simulation using solar radiation data to measure the autonomy achieved for light and heavy-duty vehicles under 2 different driving profiles, with the hydrogen produced in building and single house system for 3 different locations.
The simulation is run from MATLAB Simulink with a time step of 10 microseconds to capture the dynamical behavior of the hydrogen components. We show the intercommunication between the FPGA and Simulink. As shown in the screen, the main system signals are plotted at every time step. PV is the voltage of the battery. IP is the current of the electrolyzer. MH2 stands for the excess of hydrogen produced. PPM is the power of the electrolyzer. IB is the current of the battery, while PFC is the power of the fuel cell in the microgrid. PP is the power of the battery, and SOC is the battery stable charge. As the simulation progresses, the mass of hydrogen increases, while the energy is also stored in the batteries.
After processing the simulation results, we obtain the daily average profiles of excess of hydrogen produced in each location, for example, Mexico City, Guadalajara City, and Monterrey City. Then we computed the autonomy in kilometers for each vehicle along the year, comparing each location with the 2 different driving profiles, showing a really competitive results. Finally, I would like to say thank you to the Industrial Electronics Society, SYPA, for giving me the opportunity to present my work.